how efficient electrification. Oh boy, must be getting late already. Efficient electrification can bring you tangible economic benefits while positively impacting your employees and the environment. Got through it, Christian.
Cool. If it's hard to spell in English,
Yeah.
it's harder to spell in French. So this is my first language, French. So you will excuse me if my English is not perfect. So thanks to being here. This is very appreciated. I hope the content will bring you some add value today. So Enerprox mission is to simplify access to sustainable energy. And our ambition is very simple. Our ambition is to deliver the most competitive energy among all available energies in the market. So this is what drive our team at Enerprox. So the energy sector is ongoing a major transformation, as you know, driven by economic, environmental, and social factors. So when we talk about sustainability, this is the three pillars. So while debates on climate change continue, we see what happened. We saw what happened in the USA in the last weeks. So a lot of debates about climate change, but this is undeniable that CO2 levels in the atmosphere are rising. So the oceans are acidifying, the biodiversity is decreasing. So this reality, because this is a reality, this is some facts, this reality imposes a responsibility toward future generations, reminding us that it is time to take charge of our energy future. So this is our mindset for the team at Enerprox. So fossil fuels, although they have contributed to significant advancements, like increasing life expectancy, the gas is not the demon. So as we see, life expectancy, GDP per capita, infant mortality, economic growth, all this was driven by fossil fuel. It was not the demon. It allowed us to arrive where we are now. But if we look at the future, the transition must be done to a sustainable system because this is a finite resource. This is just the basic stuff. One of the major encouragement in that leading nations, as USA and China and others, have set carbon neutrality. So not just reduce, but achieve carbon neutral goals for the coming decades. So this is a very big challenge to overcome for the next decades. And Canada too, by the way, before 2050. We aim to be carbon neutral. So the amount of solar energy available on the Earth is about 10,000 times. So 10,000 times greater than our current needs, energy needs. We have a lot of energy that will hit the surface of the Earth each day. Moreover, the renewable energies are becoming increasingly competitive compared to fossil fuels. So this is not only a game of environmental targets. This is more an economic driven transition that we have in front of us. So due to the dramatic drop of cost, so in the business of solar, we will have some key metrics. So the cost declined 10 times past decades. And obviously the main challenge is to have some phasing between the production and the need of the building. So this is intermittency. This is the big challenge to overcome in the solar business. So the sun doesn't shine every time we need it and vice versa. So this is a big challenge. But advances in energy storage, particularly with batteries, costs have also declined by a factor of 10. So this is a key metric, factor of 10 for the price. This become a viable solution. It will become more and more viable to put some big batteries with solar to overcome the challenge of intermittency. Yeah, so an emerging concept is that the cost of solar will be cheaper and cheaper and cheaper, and one day we will have the notion of superpower. So we will have a pack of batteries, and we will have a very large solar installation. Sometimes in the day, we will have too much energy because we will over-design the solar part, because this is so cheap that we will put a lot of solar panels. So at some time of the day, we'll have too much energy. So maybe in the future, depend on the day, we'll have very, very, very low cost, low price energy, even maybe negative price, because we'll have to discharge that energy on the grid. So it will be a big, something that will change the future of energy. In the past, we used to have a upward curve for the price of energy. We bet that in the future, one day, that trend will just go down because the price continue to go down on solar and batteries. So the concept of superpower is very, very, very important. In Quebec, we are fortunate to have extensive hydroelectric infrastructure. So with Hydro-Québec, this is just kind of monopole. So this is just one business that distribute the hydroelectricity here. So we are fortunate to have 40,000 megawatt hydroelectricity installed here in Quebec. And even if we have all that kind of, we see here 40,000 peak in February, we got over 40,000. Those is very, very big energy need. So even though we have that kind of power here, hydroelectricity, we still consume about 50% of our energy is fossil fuel. So this is something that we will need to transition that gas to electricity. We need to electrify everything in the future. So we need to think about not just building, but also cars, and all the stuff will need to be electric in the future. So this is very big infrastructure that we'll need to build. So to support the province decarbonization plan, Hydro-Québec is planning over $185 billion of investment in the electrical infrastructure from here to 2035. So this is very big investment, electrify everything, more energy in production, and also energy efficiency. So you guys are in that kind of business. Do energy efficiency. It's important also to produce, but reduce. Both. We need to do both in parallel. So by the way, after 2035, we don't stop there. It will be necessary to double the electricity production again. So after 2035, even though we will have invest that kind of 185 billion, we need to invest more to achieve the carbon neutrality. And by the way, this is Quebec, but this is the reality in China, USA, all over the world. It will be very, very expensive to transition, but we need to do it. Fossil fuel is a finite resource, so one day or another it will be necessary to transition to renewable energy. So this transition also presents opportunities. So I said for the energy efficiency, you see the top about 10,000 megawatt. Économie d'énergie in French means energy efficiency. So as you see, we need wind power, hydroelectricity, other, but on the top of it, energy efficiency is a big chunk that we need to address. So this is a kind of a paradigm shift. In the past, on your left, we did a lot of energy efficiency on combustion system. And now we have two possibilities. We can electrify everything without efficiency, but this is not viable. The power, the infrastructure would be too expensive. So we need to do it in an efficient way. So at Enerprox, this is the kind of mix that we will have. We'll have some heat pumps, solar energy, hydroelectricity, and we will still have gas for the transition. Maybe about 10% of gas that we will have in the building for the peak shaving. Because for the electricity sector infrastructure, what is very, very hard is to deliver the peak power just 100% of the time of the year. This is not economically viable to deliver that kind of peak. So Hydro-Québec here in Quebec did a partnership with Énergie. This is for the distribution of the natural gas. So they have a deal that Énergie need to keep going the natural gas because Hydro-Québec need the peak shaving sometimes few times during the year, but this is very cost. It would be too expensive to do it with hydroelectricity. So this is a kind of paradigm that we need to shift. So it was for just the introduction. I don't know, guys, you are from all over the Canada? Yeah. So introduction for Quebec, I think that this is good to have an idea, but it will be also the same thing that we will need to do all around the Canada, but with different kind of price, tariffs. I talked to a colleague just before about the kind of difference that we have depend on the province, on the price. This is very, very different, the energy price, depending on where we are. So at Enerprox, we specialize in energy management. First, we have advanced technology software to do it. We integrate algorithms. We integrate heat pump with heat recovery, solar energy, and also energy storage solutions. Our vision is to transform the buildings into a decentralized. So this is another key aspect to focus on. In the past, we installed big infrastructure. In the future, we think that it will be more decentralized. So we need to think about each building is a kind of a power plant, but decentralized. Micro grid will be very, very, it will be usual in the future. So since we do energy efficiency, heat pumps, we will put some solar panels to have more energy. So this is the kind of project that we have. An example of real project. This is just in front of our siège social in English. Head office in Victoriaville. So this is about 40,000 square feet. This is kind of innovative building with good insulation for the envelope, heat pumps, solar on the facade. So at Enerprox, we appreciate to put solar panel on the facade of the building because we can match the production with the need during the winter. This is very good for us. So this is the kind of building, small building, decentralized power plant that it will be installed on the roof. So our engineers, by the way, use eQuest as an energy modeling software tool. So it was originally developed under the auspices of U.S. Department of Energy. This is a free software, by the way. Any engineer can use that kind of software. This is very precise, empirical data in that kind of software. So we can, the energy analysis for architects, for energy consultants, but also for manufacturer, we can use that kind of model. And that kind of model, what that kind of model tell us from a data standpoint is that wall, roof, infiltration, and ventilation Yeah, this is very big energy consumption. You see the color, the big chunk is ventilation, and the other color are wall, roof, and infiltration. So if we work on that kind of energy consumption for the building, for the heating, this is the target that we need to uh, to put our focus on. So this is the quest that will produce that kind of a pie chart. And for the cooling, this is also true. We'll consume very less energy in cooling, but we need to address also the cooling. With windows and stuff like that, you have all good product to avoid the sun to overheat the building. So we need to have it in mind. But the chunk also wall, roof, infiltration, ventilation, main target that we need to address. That kind of model, by the way, we can do iteration. So when we do a project, we can do 10, 15, 20 iteration, and we can compare with insulation, more heat pumps, less heat pump, change window, change the wall, the floor. So we can work with architects to bring some data, some science to say, okay, if you change that kind of material, what will be the impact on the energy bill, the durability and stuff like that. This is very, very, very useful as a tool. So for the heat pumps, Terry, your name. So we talked about the heat pumps. By the way, one thing that we I will say very authentic way. The kind of scam that we see in the market because we have subsidies sometimes. The price of the heat pumps and maybe other product will be very high compared to without subsidies. So this is a big challenge to overcome too. This is kind of business that will drive in the cost higher if we have subsidies. At Enerprox, same price before or after subsidies. What we want is volume. We don't want the niche market. We need to have very mass market. If we want to do mass market, we need to have a good payback and very low cost. So this is a mentality of transparency and honesty that we need to bring to the market. So this is very important for us to have very, very low cost of a project. So our heat pumps are the key tool for us. We saw ventilation, so we will do the heat recovery on the ventilation. We have developed modular solutions, all aluminum based, so this is very light, durable. We integrate air-to-water heat pumps along with mechanical, electrical, and electrical mechanical components. So this is a skid, plug-and-play skid. And we use glycol with water to do the distribution of the cooling and the heating. So we do the roof. We can put the just the black one on the right. We can put it on the floor outside the factory, obviously. And we also do some greenhouses. But every time is the same technological base. This is just the kind of setup around the heat pumps that would change, but this is every time the same technology under the hood. So these modules are designed for simple and rapid deployment. We need to industrialize, so this is very important for us, industrialize to scale up that kind of deployment to do the energy transition. And by the way, the era of prototyping for each building is over. I don't know for your business, but in our business, it was in the last decades, a lot of prototyping for each building and new project and new design, new engineering. We need to put it just aside and rush on the cut and paste solution. If we want to scale up the thing, we cannot do prototype at each project with a project a system different at each time. We need to cut and paste and build on the build on the same platform, technological platform. So we embedded control components. This is very, very important. We build the instrumental and control inside the cabinet, and we do the programming. So we will do the over-the-air software updates. So this is also the same mechanic with instrumental control component that will do the automation to have the optimization in real time. Meanwhile, our second key, because for us this is a key tool, is solar energy. So we need to think about the fact that approximately 1,000 watts heat the earth per square meter. And we will transform about 20% of that in electricity. So this is the kind of project that we do. Obviously, we do not manufacture the solar panel. I heard some stuff about China just before the conference. China is very, very dominant on that domain. Maybe 90% of the solar panels are manufactured in China. The other 10%, they purchase some stuff in China and they do the assembly elsewhere. No, I joke a little bit, but China is very, very dominant in that domain. Not only on the cost, but also from an engineering standpoint. In the past, China was made in China, but now it's not just made in China with low cost, it's engineered in China. People in China have very big teams of R&D, and they are very dominant to scale up and accelerate the production and bring the cost down and the efficiency higher. So yeah, this is the kind of project, and just maybe we did both building integrated PV and building in superposition of the building envelope. This is two very different products. Building integrated PV, so BIPV. The PV needs to have all the certification for the building material, and the other stuff, building applied PV, is just the PV that is applied in superposition of a building envelope, traditional. So the black one is traditional envelope, and the other one is a insulated glass unit with a thin film. And when you look at it, you don't know that this is a PV. And for now, the building owner are proud to have solar panel on their roof, and they show it and they do marketing. But in the future, they will not want to see it. It will be more and more seamlessly integrated in the building material. In fact, at Enerprox, we foresee that it will soon be inconceivable, if it is a word, not to use architectural cladding or glazing that generate energy. We think that in the future, it will be strange to install something on a building envelope that do not produce energy, because the cost will compare to something that don't produce energy. So it will be weird in the future not to install something that produce energy. So Enerprox solution for the benefits, reduce green gas emissions. This is important. We are not motivated to do projects that don't reduce minimum 80% of the greenhouse gas emission, and we can do 100%. This is a economic metric driven. If we want to substitute 100%, the payback would be longer, but we don't want to do project under 80%. This is not sufficient to motivate our team. For the internal rates of return, our target is to go over 25%. And when we heard about paybacks, this is a little bit, we think, too much focus on the payback. We need to see the life cycle of the infrastructure, and with low maintenance and operation costs, when we do the cash flow that will be attached to the life cycle of the product, we see that this is very interesting. So that kind of cash flow, we do the OPEX, the CAPEX, the financing. So we attach all the the cost that will be attached to that kind of infrastructure. And when we compare it to fossil fuel, we see that with time, this is more economic driven that we can think. The payback for the heat pumps with and because of the subsidies and tax return for now, clean tax, we can do under 5 years for now. And we think that in the future, when the cost of natural gas or other type of gas will be higher, the government would just pull out the subsidies because the market will be in place. Like what we will see with the cars, when the cars electric will compare from an economic perspective with the gas car, subsidies would be gone. So we are already prepared to be competitive without subsidies. So with modular solution, we can reduce the cost of the projects. At Enerprox, we calculate that this is 30% less from a cost perspective. And this is this is big on the simplifying the processes. So if we do with modular, not prototype each project, but modular, this is about 30% less costly for the infrastructure in CapEx. The modular solutions shorten also the project cycles, obviously. At Enerprox, the matrix is shorten the cycle of the project of the execution by a factor of 3. So this is very important in the mechanical buildings, that kind of business. The life of the project is very long. This is about 12, 18 months. So we shrink that to 6 months by doing it modular. So also the so this is a big metric for us, because if we do some volume, we need to think about the projects that we do on the building the same way that in the factory. When we produce some windows, we want to have high volume and no shutdown, and we want to keep the factory going and going. So we need to have the same mentality when we are on a construction site. We need to industrialize the project. So this is our thinking. So far, so good. So yeah. So in conclusion, just to have something to bring back in the mind. So for the sustainable energy, this is not just reduce the green gas emission. This is not just ecological. So this is reduce the energy bills, increase the property value, big numbers. From a property value perspective, when we put some energy efficiency, heat pumps, solar in the building, it increase in value significantly. Also, cooling the spaces during the winter, it will be more and more important because the heat waves, and more on the side of the factory, because now we'll have workers that will shut down the factory when it's too hot. We see here in Quebec in last summer, it was a challenge to factories to keep going during the heat wave. So we need to cool. It will be maybe in the future important as the heating during the winter. Yeah, to keep the people in good health inside the building. So improve ventilation, quality of air. So we need to bring value, not just on the energy bill or on the green gas emission. The energy transition will happen when the sustainable energy will be more competitive on all aspects compared to fossil fuel. This is what we think. So thank you.
Any questions for Christian?
That's good. Yeah.
How large of a square footage does it one of those heat pumps cover?
For us, this is 1,000 square meters, so about 10,000 square feet. This is the minimum, but this is for us. If you think about the heat pumps in general, you can have it in your house. So you have no minimum. But for us, because we have a team of engineers and we have cut and paste solution, we choose to have 10,000 square feet plus buildings. And the sweet spot is about 50,000, 25,000 is good. So if we want a good payback, we need to have big air volume without too much spaces and stuff to deliver energy. So a room like this here is a very good target because this is simple. You put it on the roof, you put the distribution is very simple, so we can do it very cost efficiently.
Thank you.
Yep. That's good. Thank you. Thank you.
Okay. Hello. Do I have a mic? Yeah. So the next session will be the Tech Services Committee meeting, and that is at 2:30.